So the next thing is Faraday's laws of electrolysis. So we want to see first law, Faraday's first law of electrolysis. So in the first one, this states that the mass of a substance deposited at the electrode, usually cathode, during electrolysis is directly proportional to the quantity of electricity passed. Meaning mathematically, you can say m directional to Q, where m represents the mass, where Q represents the quantity of electricity passed. So we say m is equal to kq, where k is a constant, is denoted by z, which is known as electrochemical equivalent of a metal. It varies from metal to metal. So from here we say m is equals to zq. This one illustrates Faraday's laws of electrolysis, where z is equals to electrochemical equivalent. That's the law. So I will say where m is equals to mass deposited of a substance deposited at the electrode in gram, meaning G, while Q is equals to quantity of electricity passed. The unit is in coulomb. That is C. And the formula for finding Q is equals to IT. That's the formula for charge, quantity of electricity. So where I is equals to current in ampere, and T is equal to time in seconds. Please take note of that. That is what we have. So it means this formula can also be written as m is equals to ZIT, since Q is equals to IT. This is another expression for Faraday's first law of electrolysis. So let's see the meaning of electrochemical equivalent. Electrochemical equivalence. That is Z of a metal. So from Faraday's first law, Z m is equal to ZQ, where Z is equal to m over Q. So we can say Z is equals to m. Z is equal to m when Q is equals to 1 coulomb. 1 coulomb of electricity. So the mass of a substance deposited when a unit coulomb of electricity is passed is what we call electrochemical equivalent. So electrochemical equivalent, electrochemical equivalent of a metal is defined as the mass of the metal or substance deposited at the electrode by passing a unit coulomb of electricity. So that's the definition. Or simply, it's a ratio of mass of the substance to the quantity of electricity passed. So it is also defined. As the mass of a substance, of a metal or substance deposited at, is defined as the ratio it is also defined as a ratio of the mass of a substance or metal deposited at the electrode during electrolysis to the quantity of electricity passed. Meaning Z is equal to M all over Q. So let's see the unit from here. Its unit is the gram per coulomb. So we'll call it, the unit is a gram per coulomb. Take note of that. The unit is gram per coulomb. Explain the statements. The electrochemical equivalent of copper is 0.00032 gram per coulomb. Just to explain the statement. So it means that 0.0003 gram of copper is deposited at the cathode or electrode during electrolysis by a unit coulomb of electricity by passing a unit by passing a unit coulomb of electricity. So that's the explanation. That's the explanation. So immediately after that, the next thing is experiments. Another question. During electrolysis of copper 2 sulfate using copper electrodes, 2 ampere of electricity is passed for 25 seconds. Calculate the mass of copper deposited at the electrodes. Take Z, electrochemical equivalent of copper, is equal to 0.0003 1 gram per coulomb. This is what we are given. So from this question, so now we are given R equals to 2 ampere. We are given time equals to 25 seconds. So we have to find M, and Z is given to be 0.00031. That is a gram per coulomb. So let's calculate Q first. Q is equal to IT, is equals to 2 times 25. So this is equal to 50 coulomb. 50 coulomb. From Faraday's first law, M is equals to ZQ. So M9 is equals to 0.0031 multiplied by 50. The mass of a substance deposited now will now be 0.0155. That is gram. That's the answer. This is a very good example to illustrate law of Faraday's first law.